Hello, I'm Lawrence. I'm here with my colleagues Josh and Manar, and I want to tell you about our project Phishnet. Now, existing phishing security tools are something of a black box. They may be simple blacklists. They don't really provide much details of how they come up with their evaluations, and the analysis is very centralized, and we don't have a great deal of trust in them. So what we are building is an explainable, verifiable security oracle. So this is a unified model for Web 2 and Web 3, but the verdicts are backed by explicit rules which explain why a particular item is unsafe. And then the process itself is verifiable. We use a TEE, which provides us with an attestation, and this proves that the code doing the analysis and the rule set were not tampered with. Then we have an agent that can validate that proof. And then finally, we have it as a decentralized system. So, of course, we're using agents, but we also put a report onto Solana. Let's take a look at our agents. So we start off with the intake agent, which will receive some artifact. This could be a URL, some text, or a transaction. And this is introduced via the chat protocol. This then passes the information to the analyzer agent, which calls a service running in the TEE to analyze the artifact. And then this produces a report, which is cryptographically signed. This is then passed to the referee agent, which can verify the attestation that the TEE produced and ensure that the report is valid and hasn't been tampered with. Finally, we have an on-chain agent, which pushes the details of this to Solana. So there we have an audit trail, something that the public can view. So let me walk you through a demonstration of this. So what we did is we sent off a URL to our intake agent and asked it to check. And this is something that, yes, that looks malicious. So the intake agent got that and then passed that to the analyzer agent, which could use the knowledge base to decide whether that is in fact a malicious URL. It made its decision, and this was done, or would be done in a TEE. We couldn't do that in this demonstration, but that would be done in a TEE. And then the details of that are passed to the referee agent, which can then validate the result. And here you can see the actual output that we got. So obviously this is all behind the scenes. These agents are talking to each other, but this is what we pulled out of our log file. So you can see there that it has come back to say that this is unsafe and this is high severity. And then it supplies the evidence, supplies the details of why this particular URL is unsafe. And this is based upon the rules that we have within our knowledge base. The next example we have here is looking at a transaction. So you could be interacting maybe via a wallet, whatever it is, but you're doing some transaction and you want to know whether that is malicious or not, whether that is safe. So again, we can pass in details of that to the intake agent. That will go to the analyzer agent, and then that can make a decision. So here again, you see it's made the decision that this is unsafe. It's decided this is critical severity, and then it's produced the evidence for that. And remember that in the full version, the decision, the way that this is analyzed and the knowledge base, etc., will be done within a TEE. And finally, when we've done that, we can send results to Solana. So we can put the report onto some decentralized file system and then log details of that onto Solana. So here we've got an example transaction that we sent to DevNet as the final part of this process. So what are we solving with this? Well, we've moved away from the black box approach to something that gives trust and is verifiable. So the users don't need to trust us, they can trust the TEE. The referee agent is there to ensure that, to show that the analysis is honest. We have composability with our agents. They act like microservices. We can add new agents. We could get agents to fetch extra data and add to our knowledge base. We get an audit trail from this. So the users can see the results of this are being posted on Solana. And our knowledge base will improve, will grow over time because we have fetcher agents that are going to be adding to the rules, adding information and evidence of malicious behavior. But also the agents can share the experience that they have as they are taking in artifacts from the users and then use that to enrich our knowledge base. Now, this is very much a work in progress, but it is in progress. We are going to carry on after the hackathon. Our next phase is to then move to look at how this can be integrated into wallets, for example. So when you are going to sign a transaction, perhaps on Solana, how we can advise you as to whether that is a safe thing to do. We also want to bring together teams and to build up a collaborative network, moving to the idea of this open threat graph. So this would be where we have a public knowledge graph of indicators that show something is malicious, but this is maintained by autonomous agents. So that is Phishnet. Thank you very much for your time. We've got some details there if you want to look at the demo or the website. Thank you very much.